Okay, so to get started with terrain nodes is pretty simple. I just do Shift A. So once you add this object, it will also add a node tree and execute it, and that's why you see erosion here. So if I change the seed value, it will update the terrain. And also it creates a new material. Here you can load image textures generated by terrain nodes, and this node group will split up the layers, and then you can do your own thing and control your colors and all that. So let me show you. Right now it's only outputting the terrain object but no images. So output an image, I'll do output and image and connect it to anywhere here, it doesn't matter. It will output every layer that you have checked as separate image, or you can have it output as different image channels. Make sure to save your blend file if you want to autosave, because otherwise it will give you this error. So I'm not going to autosave it. I'm just going to keep the image files in the blend file for this demonstration, but I do recommend you save the image files. This is where we just output from the image node. Switch to render view, and this is the sediment. Another way to add a terrain object is to add a displacement grid for cycles only, and this will use the shader to displace the grid. You won't see anything right away because you have to go into the shading tab and select the images that were generated. This is using displacement vector and the subdivision modifier. And if you change it to adaptive subdivision, which is only available if you are in experimental mode, then the resolution will depend on how close the terrain is to the camera. In this mode, however, if you click start, you won't be able to see a preview unless you change to a image editor, and then there is a terrain nodes tab here where you can switch between different layers to preview. So let's do the flow map. Make the update view every 2 cycles. The last option in the menu allows you to add a displacement grid that works both with Eevee and cycles. And generate that terrain, you can go to the modifiers, and you see 2 modifiers have already been automatically added: the subdivision surface and the height displacement. And if you go to more options here, you can select the 2 images that were generated and then adjust the height strength. You can disable and enable some of the channels, like the red channel is the sediment. So if we set that to multiply by 0, it disappears. You do have to click on the strength value to update the image data. For displacement. If you want to use terrain nodes with End Landscape add-on, it's pretty easy. Just go ahead and generate your ANT landscape. Let's say use a mountain. Now we can just hide it. Add terrain nodes grid. And just delete the current noise input and add a grid to height map input. Select the ANT landscape that we just generated. That input, image input. So let's go to shading, make a new grid, or just a plane is fine. New material. Let's just use a noise texture, something simple for demonstration. Use a map range node to give it more contrast. And let's make roughness 0.6. And scale 2. So I'm just going to make a new image. Like that. Let's make it 28. 32-bit float. Don't forget to select that. Okay. Select the node from which you want to bake, and in this case you want to bake from the map range node. And it tells you right here that you selected it. And click Bake Texture. And it should be done. Here's a bake texture. Go back to terrain nodes. Select it, erode. Oops. That doesn't look too good. So let's go back and change this to roughness 0.5. Scale 1.6. Bake it again. Let's go ahead and scale it down while we try to find what works for this terrain in terms of erosion, and multiply the height by 2. What I did here is I opened an image editor, and then automatically Terrain Nodes will use this space to display layer information, and you can select which layer. So I have water here, and I connected the preview image that Terrain Nodes generates to the shader, and I'm also using the viewport shading. So in this case, the rain frequency is every 90 cycles, and you can see how the water actually flows down the hill. And I currently have erosion disabled. If it was enabled, then where the water is flowing, you would erode those sections. So rain duration is only 2000 cycles. I'm running for 50,000 cycles, so I can go ahead and increase the rain duration so keep raining. Rain frequency, it controls how frequently the rain drops. So I now have every 500 cycles. And now I'm going to reduce that. That's too much. So now it drops very, very fast, and that's going to be a lot of water. It eventually will flood the whole map. And here you can show the height of the rain. Oh, and again, my rain duration has ended. I'm at 11,000, almost 12,000 cycles. So I'm going to increase this. I'm going to increase it to 50,000. So just keep raining the whole time. I'm going to reduce rain height, so there's less rain. Alright, now I'm going to show you the suspended sediment layer. I'll have to enable bed erosion. Bank erosion will also contribute to the suspended layer, as well as dissolution erosion, but I will get to those. For now, let's focus on bed erosion. So suspended sediment will show you how much sediment that's been eroded is currently suspended in the water and is flowing down the slope. And it's quite a lot actually, so I need to turn down either the amount of water or the erosion rate. So I'm gonna first reduce the erosion rate and drop it to 0.3. And I'm gonna increase rain frequency to, how about every 500? As you can see, each time the rain drops, it erodes a certain amount of sediment and moves it down the slope. The sediment accumulates where the water stops flowing, which is usually at the lowest point. There are two parameters. There's the thermal depth, which is how deep thermal erosion will erode the terrain based on how much sediment is on top. So let's just say there is a whole bunch of sediment on top. Then you'll see that thermal erosion is not doing anything. Now if I remove that sediment, thermal erosion, it starts to do a little bit of conversion of terrain into sediment, and that's based on the depth. This is how deep it will go below the sediment. So if I increase that, it will erode even more. Now, Whenever you have thermal erosion enabled, you also need to have, or should have, sediment slope erosion enabled as well. This allows for sediment to move away from the terrain down the slope, which exposes more of the terrain and allows for thermal erosion to have more effect. So if you see now, it'd be very strong. Whereas before, it was kind of weak. And let me show you where the sediment accumulates. I'm at a mass node, and I'm going to add terrain and sediment layers together. Now just in terrain, and now they combined. As you can see, it turned into some sort of dune. And this is just the terrain, and that's just the sediment. The sediment slope has only two parameters, which stable slope is when the sediment stops flowing down, and you can adjust that to, if you adjust it to 90, it will just stay in one place. Let's try 51. So you see the slope is much steeper now. Let's try even more. Now it's just basically just sits on top. And you can specify initial sediment layer without even having thermal erosion. Oh, looks like I forgot to change the slope. Make it 34. And this way you get sediment without having to erode the terrain. Because sometimes you want to preserve the detail, so that's a good way to add sloping, eroding sediment. You can also use a texture, which will give you more variation. Let's try random noise. Let's see what this looks like. Let's increase scale. Oh, wrong way. And oops, plug that back in. Plug into sediment. This might be a little bit too much sediment, so we might need to reduce it. Yeah, that's way too much. Where's my cycles 500? And preview sediment. And let's divide it by 10. Make it 10 times smaller. And maybe more slope and just less cycles. Oops. So now you see like these dunes, variations here. Here I have a gradient texture sloped from right to left and a noise texture added on top of it. If I have my layer set to flow map and I run it now, you see how the water is flowing from right to left, and I currently don't have any erosion enabled at all. So if I turn on bed erosion, you'll see the results of that. You can see that it turns into a river and runs around this mountain and down the slope. And it looks kind of rough, so I'm going to turn on sediment slope erosion. So it looks a little bit smoother, and if I do increase the time step to the maximum, the result is even more smooth. Bank erosion will actually give you smooth results from the start because it doesn't really focus on eroding underneath. It just kind of tries to erode the slopes as it flows down. I'm gonna increase the sediment carry strength to 10, which is too much, but just for demonstration. And again, you see the sediment kind of, if I separate them, this is just the terrain, and this is terrain with the sediment. You need to enable sedimental slope erosion so that it's not so sharp, because the sediment also flows down the slope. If you want to iterate different erosion types, you don't want to lose your results, you can always just copy the whole thing. So this is without sediment slope erosion, and this is with. So the best way to get a hand of this is to really just play around and try different things, try different water settings. For example, changing the rain duration down to just one time, one single cycle will make a different result. Sometimes higher frequency, if I change this back to 1000, and sometimes if I change the frequency down to very frequent rain, it might melt the terrain completely and give it such a unique look that it doesn't look like anything any other program can make. You see a lot of particle-based erosions. They always have that same look, those long erosion sediment lines. But by simulating 2D water flow, we can come up with extremely unique looks for terrain. So definitely try to experiment. If I reduce the rain height here down to as low as possible, what would that look like? Look, it's completely different. And again, if I increase it by 1000, another look, completely different. And just play around with different water settings. For example, this is river. You can also just scale this up to give it more detail. There is the scale. Alright. So let's scale it to 1024 and repeat the erosion. Turn this off and use basic rain and make it very small. So right now I'm inputting a 1024 by 1024 resolution terrain, but my grid is only 512 by 512. So to see the full resolution, I need to increase this to 1024 also. And it will take it a bit of time to generate a new grid. So you will have to wait a little bit. And so this is the next higher up resolution. And you can just keep doing that. You can just keep going and scaling up. Here I prepared a little demonstration for diffusion reaction. Diffusion reaction is kind of tricky to get working, but what I found to be working the best is when you have two different textures. This one is seed 17 and this one is seed 32. And when you mix them together, like you would mix two chemicals, they start having, they try to combine and dissolve one another. Here is the speed of simulation, duration, view update frequency. A diffusion is a diffusion of the A chemical, how quickly it spreads, and B diffusion is how quickly chemical B spreads. Feed rate is feeding the chemical A, so you add more and more of chemical A, and removal rate is how quickly it's being how quickly you remove chemical B, because chemical B eats chemical A to create more of B, or something like that. I didn't come up with this formula. So if I run this, now diffusion plates, it's not an actual real world simulation of anything. I actually created it accidentally when I was working on something else. But I like that it can create these slopes, kind of like Alps. Anyway, change the tiles to 45 degrees and it will be a little bit more straight down. Here edge lengths, it helps you adjust the slope. So depending on where you input your height data, your slope might be different, and edge lengths helps adjust it. So if I turn it down, it will actually make the slope for the simulation to be steeper here. And number of cycles is just how many times it simulates the diffusion plates filter, and you can kind of see progress with each 200 cycles. If you want to update it more frequently, you can turn this down to 50. If you click start now, it passes through because view update will not refresh the cached data here. But if you change the cycles, then it refreshes. If you change any of these, it will refresh as well. And now it's progressing a lot slower because updating the view costs simulation time. So if you want it to simulate faster, you want to have the view update as low as possible. You can even turn it off and just change it to 0. compared to this, it should be, yep, much faster, like 10, 15 times faster.